I'm Caroline Wagner, and thank you so much for inviting me to talk today. I'm excited to share with you my research that I do. I know most of you are researchers. I'm also a researcher, but while you're researching other people's health, I'm researching you. So I study researchers and how effective they are at working together, and how knowledge is created, diffused to others, and put into practice. So that's kind of my area of research. And you might say, people really do that? Yes. And who cares? The people who care are mostly funders. So the people that I tend to speak to with my research are policymakers who fund research. So National Science Foundation, National Institutes of Health, international groups like the United Nations, the World Bank, and so on. I've worked for all of these different groups over time to tell them not only how effective the work is that they're funding, so we can do that in retrospect, but also they want to know ahead of time, if they're putting money into a project, they want to know that the teaming organization will be done effectively and efficiently and in a way that will have the best possible outcome. So one of the things that I have done over time is to work on who is working with whom. And I'm going to start at the very big level, big picture level. And if I have a big picture, we'll be able to see it. But if not, I'll just have to tell you. So I start out at the big picture level, and then I'll work right on down kind of to the team level that you are perhaps working on yourself. How many people here are on research teams? Okay, so almost everybody. And I would say these days in our society, teaming and team arrangements, network structures of people working together are becoming almost the way we're doing business. Rarely do you see an area where people aren't working together. But I got into this area through a job I was doing many years ago. I was working in Washington, D.C., and my client at the time, I worked for the Rand Corporation, and my client was the White House Office of Science and Technology Policy, of all places. And they didn't really know how much money was being spent on international collaboration. Who is the U.S. working with? How much of our federal dollar goes to international collaboration? Who within the government is funding these kinds of international collaborations? Oh, thanks, great. So, let me just, thank you. Let's see if this works. Oh, wonderful. Okay, so I already told you, I study knowledge creation and diffusion. I tend to look at advances in 3 different ways. One is a breakthrough. Okay, a breakthrough is where a team has been working for quite a long time on a problem. And in fact, the previous speaker, I think, presented some very interesting breakthrough findings. And that would have come, he said, he emphasized many times that it was a team effort. The team was very focused on answering a specific question and had a breakthrough as a result of working continuously. The second kind of knowledge creation we look at is discovery. So here at Ohio State, we have lots of wonderful discoveries that come out of the astronomy department where they discover a new planet or perhaps a new nanoparticle. So, and those kinds of breakthrough discoveries, let's say discoveries, mostly come from equipment. So if you have new equipment that can see farther out, that can see smaller, we can see that a lot of times what happens there is discovery. And the third kind, the much more common kind of advance in science and technology is a recombination, okay? And that is where somebody with a great idea or some kinds of knowledge in a certain area find a way to combine ideas and concepts that weren't previously combined. And so as a result of putting 2 or maybe more things together, they come up with an advance in how we understand the natural world or the social world. So those three basic concepts drive a lot of what we do, and each one of those areas has certain specific measures attached to them, and I'm going to talk a little bit about the measures for you. But the recombination measure is, considered the most common kind of scientific advance. And then, how is the knowledge diffused? Okay, so this is obviously a translational science discussion. So we want to think about, well, once we have a discovery, a breakthrough, or a recombination, how does that get diffused out into the community so it's used and shared? One way, of course, is through face-to-face, just like this. And in fact, in my own research, I found through survey work that about 90% of all collaborations, collaborative teaming, begin face-to-face. Okay, so in other words, people meet at conferences, they meet at research sites, they meet in laboratories. They begin their work face-to-face. Face-to-face remains the critical way in which most people begin to work together. Side by side is similar to face-to-face, right? That is where people come and work literally together in the same laboratory or on the same project. They're working side by side. They grow in detail and understanding of one another's approach. And then finally, of course, we know we codify our knowledge in articles, patents, processes, procedures, and so on. And so we codify that information and send it out into the community, not really sure who's on the other end of that when we codify it and send it out. The ways we hear back on that usually is through citations, awards, and so on. All right, so that's kind of just to lay some groundwork about where we're going. So what I want to focus in on now is to talk about collaboration, cooperation, and teaming. These things are different. Again, they are different from one another. Collaboration is a willingness to engage with others to achieve a common end. Cooperation, we all cooperate all the time in our work. And then teams are groups of researchers with a very specific goal. So it's not necessarily one is equal to the other. And then I want to talk a little bit about interdisciplinarity, because so many people talk about interdisciplinarity, and I think it's important for us to have a good idea of what it is that we mean when we talk about interdisciplinarity. And I can tell you how it's measured by scientists like me. One of the things that we do know for sure is that the number of teams working in science, technology, engineering, math, and health research, they're all growing. And this shows you from 1960 up until the year 2000, and then there's been work since 2000, the growth in teaming and team arrangements in science, social science, arts, and so on. And so you can see that the black line, science and engineering, and also in social science, that the graph is going up. Okay, there's many more teams, and as we know, there are lots of articles now with multiple authors. Some of them have 1,000 authors and so on. So arts and humanities lags a little bit in teaming, but most other areas of scholarship are increasing their team and their team sizes. So both of those things are going up. So what is this process? So this is where I started my work many years ago. And the White House said, well, tell us what is collaboration and who are we working with? So we know when we look at what's happening across the globe, that really a global system has emerged here. How many of you work with people in different countries? So I'd say at least half the hands went up. So you have connections with people in different countries. A global system has very much emerged in science and technology. And unlike the national systems tend to reside in institutions and laboratories and so on. The global system operates as a network, and I'll talk a little bit more about that. Networks have regularities and structures. They're very interesting entities to study. It's only been in the last 20 years that we've had the amount of data, the algorithms, and the computing power to truly understand the networks themselves and to look into the regularities of human interaction. And we've done that, and I've done that in science to try to understand how communications actually operate. These networks, the drive towards collaborative teaming, the drive towards group organization in science and technology largely arises because what we're dealing with now is an abundant system. It used to be that knowledge was a scarce, very scarce resource. You had to go to mostly an elite library in a wealthy area in order to find knowledge. And you had to go there and physically sit there for long periods of time. And now what we find is that we're overwhelmed with knowledge. It's an abundant resource. And the abundant resource is always going to be managed differently from the scarce resource. So that's one of the main differences that we find between the system that many of us, including me, kind of came up in, which was much more of a operating on scarce resource kinds of dynamics, to now an abundant system where we are working with other people because there is so much information we can't individually take it in. Okay, so let me tell you about a project I worked on when the White House asked me, well, tell us about collaboration. So what I did was I found 100 scientists in the United States who were working with people from, especially in this case, developing countries. I was particularly interested in this question of why they would work with someone from a developing country, assuming that people in developing countries probably weren't as world-class as they were. And so I did a survey in which I asked those folks, this is supposed to be a little movie. Do you know how to turn my movie on? No? Okay. So what I did was ask those people why they were working with someone from Malaysia, Ethiopia, Egypt, Peru, okay? And the surprising finding of that research was that in 1/3 of the cases, 1/3 of my 100, the researcher was from that country originally. Okay, so now I was doing this research in 1992, okay? So they were from that country originally. At the time, that was a bit of a surprise. But what we found was that those people had come to the United States, studied here, become a world-class scholar in order to gain access to and compete successfully for grants from the US government. And in turn, as part of their research, turned back to people from their home country in order to work with them. No, my little movies aren't going. Sorry, there's a little movie to show you how the network grows. Because in addition to the 100 connections that I identified, I found that they weren't just a bilateral connection. Usually, there was a third person involved, or even a fourth person. And so while you see the connections to developing countries, those connections didn't end there. They connected back to Europe. They connected back to Japan. And so what I found was a network of interconnections that was largely seeded with US government money and was working at the world-class level in terms of development of new scientific knowledge. Now, the other really amazingly interesting thing about what's going on in science today at the big picture level is the number of countries working in the system. This is the data from 1980 of the top countries, the countries responsible for 85% of all research and development spending in the world, okay? So this is in 1980. You can see it is a very small number of countries. And what you can see here, we can see that we've added some countries in terms of the quality and the scope of spending. And then if I were to add on the numbers of countries, we would see many more added on. So countries like Malaysia, like Kenya, Brazil, Australia, of course, is a first world country, now India, and so on. And so many of these countries now participate in international collaboration in science. And I would suggest to you, this is what my research shows, is that this growth of capacity around the world is largely an invention or an innovation that's created by the United States. It's through the funding that we have put forth and then the connections that have been made across these countries. So, lots and lots and lots of researchers now choose to collaborate. Is that a good thing? Are we wasting a lot of energy taking time to share one another's ideas? Are we benefiting from this kind of activity? And how are we benefiting? And this is what NIH and NSF and other funders want to know, because they can see that increasingly they're funding these international collaborations. And not only that, but most importantly, the more elite the scientist, the more likely it is that that person is working at the international level. All right, let me repeat that because it's so important. The more elite the scientist, so the more elite you are, the more money you have, the more citations you have, the greater your reputation, the more likely it is you are an international scholar. You're working with people from other countries. Okay, now, NIH, even Congress, I also worked for Congress, and I can tell you that many, many Congress people would say, why are we spending a lot of money funding people to work with China? Like, isn't that kind of the opposite of what we want to accomplish here? And it's not just in the United States the question's being asked. That question is being asked in other countries too, where they also recognize that international collaboration is growing and that their elites are working at the international level. So, one of the things we know is collaborative work is more highly cited than other work. The more countries you have on the address lines, the more citations you get, okay? International work appears to be of higher quality, according to peer reviewers. The more countries you have, the more atypical combinations you have. Remember back to recombination of ideas? Well, when you have very unique and interesting and novel kinds of combinations of ideas, that's called atypicality. Atypical, not what you expect, okay? So the more countries you have, the more atypical the research is. Heterogeneous teams, that is, people from different fields, from different kinds of skill sets and so on, tend to be more creative. Teams with women on them tend to be even more creative. And in fact, a study was done in which teams that were 51% women, I'm not sure how you get there, but that's what the study said, that are 51% women are much more productive and creative than other teams. New ideas take longer to be recognized. Okay, and so teams have several things going for them. They also have things going against them. They take longer to publish because their work takes longer. They have to coordinate. They have to learn each other's language. It takes time to coalesce your ideas together. They take longer to publish. And the work tends to take a little bit longer to get recognized. But over the long term, the teams are much more highly cited over time. Okay, so it takes longer to get out there, and it takes longer to get recognized, but it eventually outperforms other kinds of work. So we know that in addition to seeing all these teaming activities going on and collaboratives, we are also increasingly bombarded with this idea of openness, open scholarship, open sharing, open data, right? And so what does that mean? Okay. I could spend the whole day just talking about openness, and so I don't want to do that. But I think most of you have probably seen it in two ways. One is being encouraged or discouraged from publishing in an open journal, an open publication like Public Library of Science PLOS is an open access journal. You can publish in there, and it's immediately accessible to anyone who wants to read your work. And then the second thing is open data, and that is where you put your data and make it available online so someone could come and validate your work if they so chose to do that. Those are the two aspects of openness. Again, in my book, Collaborative Era in Science, I make the argument that an abundant knowledge system is going to, by nature, create the demand for openness. Okay? These are things that have to happen together. It's not as if you would have an abundant system that also has a lot of closed subsystems within it. It's just not going to be part of the nature or the dynamic of that system. And so I know some people out in the world are criticizing the publication houses and so on, but it doesn't. That's really not the point. The point is that we're going to move towards openness because of the nature of knowledge and the way knowledge is created. So if we look at one thing I did, this was in Nature, this was published in Nature, where we looked at countries and we said, okay, how open is that country to collaboration? And we did this with a bunch of variables and statistical, this, that, and the other thing. But what we did is say, okay, here's a country, their people move around, they have open international collaborations, they publish with other countries. What we found is that those countries also had higher impact of the research measured by citation strength. So what we found is that the countries, open countries, have a higher impact of their research in general. And somewhat surprising members were, this is like a Cartesian space, and so the upper right-hand quadrant is kind of your heaven quadrant there, and it shows you that they have high impact and they're highly open. And the highest impact, highest open country is Singapore, which was a big surprise to me. Switzerland, not so surprising. But in the top right country list, you see well, the United States isn't there. That's partly a function of our size. The United States is over here on this side, the top large bubble. But China, Japan, Korea, Russia are all in the bottom right quadrant, less open and lower impact of their research. In other words, openness and impact seem to be at least highly correlated from our analysis. Again, open countries have higher impact. The connected institution has a higher reputation. People who move around, meaning they go from one place studying and researching to another place, especially move countries, have a much higher citation rate than people who don't move. Open publications like in PLOS gain more citations and have a higher impact. Open teams have greater variety. So this is where you have a team and people are invited to join. The team itself has multiple disciplines on it. Those teams, open teams, tend to have more variety in the way in which they approach. And if you think of it as an open system, open systems can allow and welcome new players to come in. Okay, so in other words, it's not a football team of just 11 people. The teams can refresh over time. All right, so now I just want to touch a little bit on interdisciplinarity because in translational research, you work a lot of times across disciplines or with disciplines coming together to share knowledge and information. And in the kind of work that I do, people are very, very interested in how interdisciplinary is it? How many disciplines is too many? If you have everybody with a completely different discipline, are we really gaining or losing in terms of knowledge sharing? We all know that when you're working with someone from a different discipline, it takes a little time to learn each other's language and to share each other's capabilities and skills. So what is interdisciplinarity? Okay, so this is how people like me think about disciplinarity and interdisciplinarity. And what does this show? There are three aspects of interdisciplinarity. And this is all measured by looking at the codified word. Okay, so this is all measured using published articles. But the idea is that in interdisciplinarity, you are looking for diversity. You will want to identify how much diversity is coming as a result of your interdiscipline team. And increasing diversity is a combination of three things. On the top is the variety, as in numbers of disciplines. Okay, so you can see in that circle, there's a big green one, so let's just say the big green one is medicine, let's say, and then you might have in there immunology and bacteriology, okay? And so that is a variety created by numbers of disciplines. On the bottom right, you have what's called disparity. Now, if an anthropologist is on a medical team, the idea is that those two fields are disparate. They're far apart from each other, okay, as opposed to immunology and medicine, which would be closer together. And there's measures of all that, too. So that is the measure of disparity. How disparate is the team? And then on the bottom left is balance. So you have a team of people, and if the team is mostly medicine, and the anthropologist comes in once a month to just give some feedback, that's not a very balanced kind of diversity. In other words, it would be, the balance would be so heavily towards medicine that it's much less interdisciplinary, okay? And so what happens then is each of these features is measured, and then in the middle, you get a measure of interdisciplinarity measured as what's called diversity. And that is how people in the field of what's called scientometrics uses this measure to try to understand how interdisciplinarity occurs. Now, one way that we think about this, and I mentioned this disparity, right? This is the map of science. This is an actual map of real science. It's based on the referencing behavior across fields. So you take all of the medical articles and see where are they referencing. Are they referencing biology? Are they referencing chemistry? Are they referencing psychology? And so on. And taking the entire corpus of all published articles, you actually come up with a connected map. Okay, so I don't know if you would expect to see that, but I think that's amazingly interesting, that really all knowledge is connected. And you can see here, this is the medical specialties right in the middle. That's not by chance. That's not by chance. They are the group in the middle that tends to hold everyone else together, right? Interesting. And so you can see that they are very close to infectious diseases here, close to brain research, health professionals, and so on. Here's chemistry, okay? So chemistry is a little bit farther away. You can see across the connection. Hopefully you can see the gray lines between them, okay? Math and physics is over here. Biotech, chemical, biology, earth sciences, humanities, and you can actually go in if you'd like. I'd be happy to connect you. You can go in and play with this map. And you can see who's connected to whom and how and why. And so, and the other interesting thing to me is that this, if what you need to do is think of it as a circle. Okay, so this is a flat map, but it's actually a circle because over here, math and physics goes back again over here. So everything is an interconnected map all the way around. So if we look at taking those different fields then, pulling those out and then saying, okay, what's going on within that field? The other amazingly interesting thing to me is that collaborations and international collaborations are growing in every field. There isn't just one or two fields that are getting more collaborative. It's happening in every field, even in math, which you tend to think of mathematicians as rather isolated. But even the mathematicians are collaborating more over time. And so this shows you physics up here, shows you this is single author pairs, small teams, large teams, and so on. Same thing, and I included biomedicine so you could see yourself. You can see single authors going way down over here. Very few things are single authored anymore. Author pairs, small teams, and large teams. All teams are going up, while individual sole authors are going down. Astronomy, of course, has always been a heavily teamed science because of the equipment that they have to use. So that gives you a little bit of an idea. Now, here's another fun way to think about how to understand yourselves, okay? So this is the Journal of Acta Pediatrica. And so what I did was take that journal. That journal is there in the middle somewhere. Again, you have to think of this as a three-dimensional space. And this shows you all the journals that are cited by Acta Pediatrica. So what you can see in this is the clinical perinatology, right? Lancet Global Health, Environmental Health, and so on. And what you can see is these are clusters of journals that are co-occur very, very intensely. And in the middle then, you can't really see it, but in the middle is your journal of interest. Every field has a different footprint of their journals. And again, I can show you where to do this if you're interested. It's really fun. And you can go in and see, are they loosely connected? Are they tightly connected? Who and what journal groupings are connected to one another? And you can get an idea of the interdisciplinarity, or not, let's say, of a field based on the journal footprints that come out as a result of understanding the collaborations and the connections between journals. All right, now I want to come down just a little bit. I probably don't have much more time. So, and I want to just come down now to the team itself. What are we understanding about teams? Hopefully you had a chance to go to the NIH team building website. How many people have used that, the team building website? Oh, please use it. It's really filled with really great information. But the idea then is that what people like me are doing is trying to understand how teams can work as effectively as possible. So we know that some teams co-locate in one place and work very closely hand in hand. Other teams are dispersed across time and space. And so all of these teams have to do some kind of collaborative problem solving. So what is that? First is they have to develop a shared understanding of what they're doing. That is where group members share common goals when solving a new problem. Accountability, and that is where the contributions of each member and the team as a whole are understood and are made visible to the rest of the team. And of course, as we know, many times you also have to explain that to your evaluation team that you are you're being held accountable to. Differentiated roles. So we know that the best teams make sure that they're differentiated roles, but ones that are all valued well, where group members draw on the expertise of individual teams. And one of the other things that we find is that the teams that can self-organize are the most effective. That is where people aren't told to be on a team, they are offered the opportunity to be on a team, and the team welcomes them in. Self-organization is much more effective than being assigned to a team. And then interdependency, group members depend on the contribution of others to solve problems. So those are the basics, and there's just a new article out today, in fact, by one of the top team science professionals about how each of those parts of teaming can best be achieved, and then how they can best be measured. So finally, I have a map of all the scientific collaborations around the world. It didn't start out with a map behind it, but you can see the map of the world behind it. This is all collaborations across the world over 4 years' time in the 20 knots. And you can see that the points of light are everywhere in the world. There's a lot of activity, of course, within Europe, across the US, and so on. But one last thing I want to mention. I did a count just for fun to see how many international collaborations were being done from Ohio State. And what I found is for one of the years I looked at, it was 22,000 international collaborations resulting in articles from Ohio State. And then I thought, well, how much is Ohio State researchers working with people from other universities in Ohio? And I came up with 400. 400. So one of the things that I said, remember I repeated it, that the more elite the scientist, the more likely they are working at the international level. One of the problems that comes up there is that as reputation drives people up in terms of visibility, the local level can be kind of starved for attention. And so where we see our faculty researchers become more well-known, hopefully, and we like that, they become internationally connected. The question is, does the knowledge get reintegrated at the local level and become locally valuable? Because remember that most collaborations begin face-to-face. How do we ensure that the local level is truly enriched with the knowledge that we're pulling down from this amazing global network of science? So thank you so much for your attention. I hope that was enlightening and enlivening. And if we have time, I'd be glad to answer questions. But if not, it's easy to find me because my name is Wagner, W-A-G-N-E-R, .911. That's for real. Call me in an emergency. But 911. And so I welcome any comments or questions through email. Thank you. Do we have time for questions? Yes? Okay, great. Anybody have questions?
So what was your answer to the senator or representative asking you what are we getting from these collaborations?
Great question. So one of the things we know from studying networks, and this goes back to my comment about reciprocity and self-organization being very, very effective. The more you allow teams to self-organize, the more optimal or the optimality is increased. So if you allow people to find each other and to work together, then what happens is in a network, you have to have reciprocity. You have to be able to say, I'm working with Dr. Lee, and I'm really getting a lot out of this collaboration. We're really sharing a lot. He's giving me a lot of data. I'm giving him, a lot of my data, and we're really sharing. And I feel like this is gaining in terms of value for me. So one of the ways that we look at that is to say, okay, if you allow your team to self-organize, and it sustains its work over time, right? Especially at a distance, we know that there's a lot of transaction costs associated with doing that, that we know that the teams are enriched as a result of their collaboration. So the answer, that's a long way around, the answer is yes. The more that we allow these kinds of exchanges among equals, and the more it's reciprocal, everybody gains from that. No other questions? All right, well, I mentioned that I have a new book out. It's free on Springer Link. So it's called The Collaborative Era in Science, all about these kinds of collaborations. So it's available on Springer. And I'd love to have any comments if people dip in and take a look. All right, again, thank you so much. Appreciate it.